All right, so we have an idea of how to increase our percentage of odds of getting an interview. We also learned about Big O notation and how we can use it to look at our code and analyze whether it is efficient or not. Using our knowledge up until now, let's move to another important topic. At the end of the day, an interview is a way for the company to find out, can you solve problems that the company or employer has? Because if you're able to solve their problems, then you're valuable and you will produce more value to them than the salary that they're paying you. That is what a technical interview tries to answer. Now, we can be smart and strategic about where we apply and how we apply to a company, and we learned about that in the previous sections. But here comes the big challenge. You got an interview. What do you do? Over the next couple of sections, we're going to tackle this question and get you as prepared as possible for the coding interview. And we're going to get very technical. I know up until now we haven't seen that much code, but we're going to get into the nitty-gritty details over the next couple of sections. But before we dive into coding problems, data structures and algorithms and all of these fun coding details, we must first understand this one principle: how to solve problems. You see, if we know every single algorithm in the world, inside and out, you know all the data structures, you're the best coder in the world, well, it doesn't guarantee that you will succeed in a technical interview. This section is meant to prepare you so that you have the foundation laid out, so that after this, all you need to succeed in the technical interview is the actual coding aspects of the questions. You see, it's not the smartest interviewer that gets hired most of the time. It's the interviewer that is able to answer this fundamental question. Will you solve the company's problem? If you're a genius, but you can't talk to people, you don't work well with others, or you write ugly code that people don't understand, or you can't communicate a solution to a problem, then you won't get a job. You see, it's not necessarily about the solution to a problem in a coding interview. It's about the thought process and knowing the trade-offs between data structures and algorithms, space and time complexity. Just like in real-life coding, you don't memorize things. You have to deeply understand them, understand the trade-offs. So that's what we're doing here. I know I'm taking a long time to get to my points, but we're trying to build the fundamentals before we dive in really deep so we understand the why of each thing. We're building this foundation by first understanding the Big O, which we did in the previous section, and then learning how to solve these problems. In this section, I'm going to show you step by step what we need to do to solve problems in a way that companies really like, so that you succeed in this coding interview. We're going to look at some sample coding interviews from Google and see what they did and what is the ideal process to ace this interview. So that once we have these foundations, we can use data structures and algorithms to solve our problems. Because the interview isn't about your ability to memorize data structures and algorithms. Most people make that mistake. And interviewers can detect right away who actually knows these things versus just memorizing them the week before the interview. So, how can you ace the coding interview? In this section, we're going to talk about the technical interviews and how to succeed in them. I'm going to show you what a successful interview at Google looks like, and then break everything down step by step as to what you need to do. I will also give you a nice little cheat sheet to summarize everything in this section so that you can always view it before an interview. At the end, we're going to solve a coding problem ourselves, just like you would in an interview, and analyze different solutions to that problem based on what we have learned up until now. We're going to figure out the best way to solve the problem, but also analyzing different Big O solutions when it comes to space and time. By the end of this section, you're going to have a big aha moment. I guarantee it, where we're going to take everything we've learned up until now into our data structures and algorithm sections to really understand the trade-offs. Let's get started, shall we?